Welcome to the ultimate 2.5 hour PySpark crash course. Let's start with the question: what happens when your dataset grows from a few megabytes to 100 gigabytes? In the real world, the big data does not care about your local RAM. If you want to build production grade data pipelines, or do you want to deploy any machine learning models at any scale, and you want to get a six-figure salary as a data engineer, you need to master the PySpark, because PySpark solves the problem of processing massive petabyte scale datasets efficiently by combining the simple Python programming with the high speed distributed computing provided by the Apache Spark. In this complete masterclass, we will be covering all the most important transformations, like handling malformed records to select, to with column, to drop, to string functions, to explode, and whatnot. You can see on your screen the topics which we will be covering. So this will be the detailed PySpark tutorial, and after completing this tutorial you will be able to work with PySpark, and everything you need, including the source code, datasets, and the notes, are linked in the description below completely for free. So hit that subscribe button, open your code editor, get your coffee ready. Let's turn you into a big data expert. Let's get started. So the first question is obviously, why PySpark? What is the problem which PySpark solved for us? So before PySpark, you know that there was a concept called MapReduce. And if you don't know, please do watch my 9 hours Apache Spark tutorial. Then you will be knowing what exactly was MapReduce. So coming back to the topic, before Spark, MapReduce was the industry standard, right? It used to process the data by breaking the data into a mapper and a reducer. It was very efficient with the small datasets, and developers used to purely rely on the localized Python. But when the large datasets come into the picture, these were not more efficient, because it was having a very slow performance, as MapReduce wrote the intermediate results to your physical disk. And as you know that retrieving data from disk is very slower, but PySpark processes the data in memory, which means your RAM, which makes your PySpark 100 times faster, right? And even in MapReduce, the coding was very complex. Usually it was Java dominance, and whenever you need to create the MapReduce jobs, you required hundreds of lines of complex Java codes for just even simple task. And then obviously the pipeline follows very rigid code, which requires the data engineers to entirely separate the things for data engineering and for machine learning. So these were the problems present before PySpark, and with PySpark we had solved all these problems. So now, as you can see, PySpark solves the problem of processing massive petabyte scale dataset efficiently by combining the simple expressive Python programming language with the high speed distributed computing power of Apache Spark, right? It eliminates the limitation of memory bound single machine computing for data engineers and machine learning workloads. So now if I talk more about the core problems, the first problem which PySpark solved is big data scalability. If we talk about traditional Pythons that used to run on a single machine, and it used to crash when dataset actually exceed the available RAM size, but PySpark distributes the data across the clusters of computer, and which helps you to process the massive data seamlessly, right? Then the second is complex data transformation. Obviously, it provides a rich set of API to clean, filter, aggregate, and join structured and even unstructured data across even thousands of nodes. We will see that that's actually the how, but now we are understanding the why. After why, we will go to what, then we will go to how. Cool. The third one is unified analytics and machine learning, and we just discussed that, because PySpark allows data professionals to use a single code base to prepare the data, to train the model, and to process the real-time streaming data as well. The fourth is performance optimization, and it is self-explanatory. If you know the Spark, you know I am talking about Spark Catalyst Optimizer here. So it automatically analyze and improve the efficiency of your code execution plan using obviously the Spark Catalyst Optimizer under the hood, which significantly reduces the computing time as well. And the final one is fault tolerance, and you know if a single node in any computing cluster fails. No problem at all. PySpark will automatically recompute the lost data and it will ensure the tasks are actually getting completed successfully. So this is why behind PySpark. Now you are clear that why PySpark exists in the market and what problem PySpark solved. Now let's jump into the what and what means PySpark definition. So PySpark is a Python API for Apache Spark, right? An open source engine for distributed computing and big data processing. It enables Python developers to process, analyze, and manipulate the massive datasets across clusters using familiar Python syntax and libraries like pandas. So this is self-explanatory, but there is a diagram which is very important to understand that resonates the PySpark core modules. So we have Spark Context, Spark Session, RDDs, DataFrames, Spark Streaming, Machine Learning Libraries, and SQL. These are my core modules available in the PySpark for processing the large data, even for the machine learning and even for the real time we have Spark streaming. This is very important to understand the key core modules available in the PySpark. Let's now quickly install the Databricks free edition as well, which we will be using. So for that, you just type on your browser Databricks free edition and then you click on enter, and then you need to open the Databricks portal, and here you will get the option called Try Databricks. Click on that option and then you need to sign up. So you need to mention your email ID here. Then you need to click continue with the email and you will be receiving a verification code. And once you had verified the code, you will be able to log into the Databricks portal. Cool. So this is a free edition and we can literally use the free edition. That's more than enough for us. Cool. Now it's the very time to focus on how of the PySpark, right? And how means obviously hands-on, right? For that, let's start with PySpark transformations. And first thing, we will understand reading the data using PySpark, and we will read the data from CSV files, JSON files, and Parquet files. So let's go to the Databricks workspace. And here I am in my Databricks workspace. First thing first, I will create a new notebook. And I will name this notebook as read files from PySpark. Read files, let's say using PySpark. PySpark. And then what I will do is I will go to catalog and I will upload these files as a volume. I will go to my browse layer. I will click on this demo and I will click on create a volume. And I will name this as, let's say, PySpark demo. PySpark demo volume. And I will make it as a managed only this time and I will click on create. And perfect, I had successfully created my volume. This is my PySpark demo volume. And here I will click on this one and then I will say upload to this volume. And I will click on browse and I will upload 3 files. First is this Parquet files, then this weather file as well, and then my customers 100 file. So I will upload 3 files, weather.parquet, weather.json, and customer100.csv. Okay, and then I will click on upload. So I had successfully uploaded all the 3 files. Now I will just go to workspace and I will open this one, read files using PySpark. And here I will open my catalog as well. In parallel to that, for that I will click on this option. Then I will go to my browse layer, then demo, and then my volumes. And then this is my PySpark demo volume. And here are my 3 files. So first thing what I will do, I will create a data frame. I will say data frame is equal to spark dot read. So this is the command spark.read to read the files. Let me give some context as well. So here I will give the heading as reading CSVs. Okay, and I will click on shift plus enter. And then here I will try to read the CSV file. In order to do that, the function is spark.read.format. And then inside the format, we mention the type of file. In my case, it's CSV file. And then I will say backslash and I will go to my next tab. Okay. And then here you can see Databricks is automatically recommending me what should I put next. But I will put my own thing one by one. So I will say dot option. And first thing I will say header. And then I will say true. Okay, and this I will say in the Boolean way because this is the much professional way to define the header. And what this option do is it will treat my first record as the header. Okay, and then I will again put one backslash and I will move to the next tab. And then again I will say dot option. And now I will say infer schema. What this do is it will go to my file and it will read the file content for first few records and it will detect the schema type, whether it's a boolean or integer or float. So that's what infer schema is. And then I will say dot load, and inside the load I will mention my CSV file. So here I will click on this option and I will just click, and here I got my CSV file location. All I just need to do is I just need to wrap this up inside the double quotes, and then I will just say df dot display. Okay, and this should work. Let me run this. It's it started running, hopefully. If you notice here, we are not able to see the jobs, stages and tasks because I am using the serverless. That's the reason I'm not able to see that. This had worked successfully. I had successfully loaded my CSV file data inside my data frame. So this is the data and it looks pretty awesome. This is how you can load the CSV file using spark.read.format. Make sense? Perfect. Let's now also load the JSON file. So I will again give a heading. I will just say reading JSON. Okay, and I will say shift plus enter. And now we'll create another data frame. I will say df underscore JSON. And again, I will say spark dot read dot, and see guys, I hadn't done anything, but Databricks automatically started recommending me what I should put next. Right? This is really awesome. That's something which I really love about Databricks. Now I will put my own. So I will just ignore whatever Databricks is saying. So I will say my format is JSON this time. Again, I will put backslash and then I will say option. And here I need to mention infer schema. By the way, infer schema is not a good thing to mention, to be honest. It might go destructive as well. It's always recommended to define schema because you never know, right? So next thing I need to mention is multi-line. Because JSON is a multi-line file, so we need to mention multi-line is equal to true. Okay? And then again, I will mention the last but not least, which is load. And inside the load, I will literally copy paste my location of the JSON file. I will just go to demo, then volumes, then PySpark demo, and I will literally click on these two arrows and it will automatically paste my location. And once this is done, again, I will say df JSON dot display. I guess this should work. Let me run this. And perfect. It had successfully ran and I am able to see my data in all the columns. And if you notice, it is successfully detecting the data type for all the columns. 1, 2 means double, 1.2 means double, ABC means it's a string format. So infer schema is very helpful. But again, there are pros and cons. So be mindful whenever you are using the infer schema. Okay. The last, now I will go with reading the Parquet files. Okay. So I will say shift plus enter. And now I will create another data frame df underscore parquet, and then I will mention again Spark. Please read the parquet file. Okay. Here I will mention parquet, and then I will just mention the load, and inside the load I will just copy paste this parquet file, and then I will just say please display me this data frame, the df.parquet display whatever is the data inside this parquet file, and I will just hit run. And see guys, it had successfully displayed me the data for the weather Parquet file. This is something which is very helpful, and I really hope that you now understand how we need to load the data. Let's quickly revise. In order to load any kind of file, you need to mention spark.read.format, and inside the format you need to mention the format of the file, either CSV or JSON or Parquet. And then there are specific options for specific file types. And especially this is valid for JSON, where we have the specific option exclusively for JSON file, which is multi-line is equal to true. So this is how we create the data frame by using the file. Okay. And this is something which we as a data engineer regularly do. We consume the data from the files and create the data frames on top of that. Okay. And then obviously transformation and other things. So this is pretty much about reading files using PySpark in the Databricks. Make sense? Perfect. Let's now discuss about handling malformed records. When reading a standard file formats like CSVs or JSON, we can use the option when we are loading the file using dot option, and then we can mention the mode parameter to control how can Spark behave when we are actually encountering with any kind of faulty lines. So we have three kind of modes. First is permissive mode, which is the default mode as well. It sets the corrupted fields to null and inserts the original malformed row into the designated error column. Okay. And then we have drop malformed. It silently drops any rows containing the elements that is not exactly matching with the expected schema. And then we have fail fast, which immediately aborts the execution loop and throws a malformed record in parsing exception. Let me show you how we can work with these modes. So let me go to my Databricks notebook. I will use the same notebook of reading files using PySpark. I will just copy paste my JSON one, and I will go to last and I will mention a text saying malformed records. Okay. And I will say shift plus enter. And then here I will copy paste my above script. And after the multi-line, I will mention the option. And then here I will pass the mode. See guys, I guess Databricks is mind reader. So it actually reading my mind that what I am actually looking for. Okay, so I will just press tab, and then I will again press tab, and this is the permissive mode. And here again, I will just put backslash, and then I will run this one. And it has successfully ran the results. Similarly, you can mention here, let me copy paste. And you can mention here drop malformed. Just say drop malformed, and let's run this. So it will actually drop any kind of row which will not match with the schema. And the third and last one is fail fast. So I will just copy paste and I will just change here fail fast. And I guess you got it what I mean, right? So I will just run this as well, and my work is done and dusted. So this is how you can handle the malformed records using the dot option mode. Okay. Let's now try to understand how we can define the schema within the Databricks. Okay. So for that, I will again create a new notebook, and I will just click here and I will say notebook, and I will name this notebook as define schema. Define schema. And yes. So in order to define schema, we have two ways. First is using the struct type and struct field way, and second is using the DDL way. Okay, I personally love the DDL way, but I will show you both of them. So let me first give heading to this. So this first way is using struct type and struct field. Okay, so let's understand this. Shift plus enter. I will explain you what is struct type and struct field, but the important thing to note is in order to use these functions, we need to import these functions. Okay, so I will say import PySpark dot SQL, import star, and then I need to import PySpark code SQL dot types. Okay, this is the library from which we will import all these things, struct type, struct field, and other kind of data types. And yes, and I guess I just need these two things. I will just say control plus enter and it will even start executing. So it had executed both of the code, and then here I will define my data first, and let's go step by step. Okay, so let's say I will just define two records of dummy data. Let's say Alias, and then let's say age, let's say 28, and then let's say his salary, and I will say 5500.50, let's say. Okay, and then let me define one more. I got few auto recommended by Databricks. I will just click on tab, and I will just remove the David from the picture. I don't need very big data to help you understand what exactly I'm doing. So this looks fine to me. I will just remove the comma. And then after the data, I will define my schema. So earlier, if you remember, we used to say infer schema is equal to true whenever we are trying to fetch the data from the file, which is a way, okay, which is definitely a way, but that's not a very good way, right? So the good way is either using struct type or struct field, or either to define the DDL. Okay, it is automatically recommending me the struct type and struct field. So I will just click on the tab, and I will explain you now what is the struct type and struct field. So the struct type is a collection of list of struct field. Okay, so let me write it down here. I will write the comment. Struct type is nothing, just a collection or list of struct field objects. So this is about struct type. So it's just a collection or list of struct field objects which defines the complete structure of a row in your data frame. So now we are clear about struct type. So what is this? What is these things? This is the name of the column, as you can clearly see. And this is my null label. If I say true, this means name can be null. But if I say false, this means name cannot be null. So basically it indicates whether the value is null or not null. So now let's understand the struct field. Struct field defines the metadata for a single column. Okay, it accepts three primary parameters. First is the column name, then the data type, then the note null. Okay, let's write that as well. I will say struct field defines the metadata of for a single column. Make sense? So now as I had created my schema and I had also defined my data, I will run this complete cell. Okay, indentation error, no problem. Thank you Databricks for fixing for me. Okay, indentation error is there. I guess now this is fine. Yes. So I had successfully ran my data frame. It's time that I should show you the data types. For that, I just need to say df.print schema, and I will just hit run. And see guys, it had successfully defined the schema by name, string, age, integer, and salary float. And if you see, null label is equal to true, which was our third parameter. Okay, this is one way to define your schema, and whenever you create the data frame, you can mention your data as well as schema inside that, and this will get your work done. Okay. But I personally don't like the writing struct type, then struct field, then name, then data type. A lot of things is required here. So I don't like it. So there is another way, which is known as defining the DDL. Okay. So let's give that heading as well. Defining the DDL. Okay. Shift plus enter. And here I will show you how I actually define the schema. Okay. So for that, let's say I will say my DDL schema, and then I will add triple double quotes. And now I will see, guys, it is automatically recommending me. Now I will mention my column as well as data type, and then I will close the loop by triple quotes again. So this is how I like to define my real schema. Okay. So once this is defined, all I need to do is just to pass it here and my work is done. Okay. So this is the another way, and this is something which I personally like and I personally follow whenever I need to create the DDL, because it gives me the vibes of my data warehouse where I am defining my DDLs. Okay. So this is all about defining the schema. You can define either of the ways, both are fine. This one looks more professional, so that's why I personally love it, but it's totally up to you which way you want to use. Okay. Now let's completely focus on the transformations. Okay. So I will create a new notebook and I will name this notebook as PySpark Transformations. And now let's deep dive into the transformations. So first thing, I will just go to schema tab and I will just copy paste my libraries here as it is, and I will say shift plus enter. And then first transformation, let's talk about select transformation. This is the very basic transformation. So let's start step by step. In order to do that select transformation, I will go to my workspace, go to read files using PySpark, and I will copy paste my Parquet file code here, let's say, or JSON file, anything. So I will copy paste my Parquet because this is the widely used one being a data engineer. So I will just copy paste here and I will just do shift plus enter, and I will let this run completely. I want this one to be go up. So I have an option called move up. So I will just click here and it will move up, and now it looks pretty much beautified. So we have data, we have couple of columns. In general scenario, you will never be required to have all the columns, and that is also not an optimized way to have a select star. Usually we try to prune the columns which are literally not required. Okay, so in this case, let's say I only need min temperature, max temperature, and the rainfall index, and also let's say rain today. Okay, so if I need 3 4 columns, why I should do a select star on all the columns, right? That's not a good and efficient way, right? So in order to handle this kind of scenario, we can use select transformation. Let's create a data frame df underscore select, and I will just mention my df parquet. Will copy paste from here, and then I will say dot select. Okay. And inside the select, there are two ways to define your columns. First is you can directly mention the column name. In my case, let's say this is min temperature. So I will just say single quotes min temp. And second way is to use the column function. Okay. And then mention the column name. Let's say max temperature. So both are okay. Both works as it is. There is no difference. But the second one is something which I personally like to use because it gives my notebook a professional look, and it kind of convey to the third person that this is the column which I am pulling. Okay. So it's up to you. Both will work. So let me run this for you. Okay, column is notified. Okay, no problem. So I need to import a library which is pyspark.sql.function, and here I will import star. So this will import all my SQL functions. So it's very important whenever there is a error like that, you should import all the libraries instead of importing a single library. So again, I hadn't ran this. So let me run this as well. So I ran this now. So this time it should not be throwing me any kind of error. So let's run this time. And yeah, perfect. So if I say df underscore select dot display, I will be able to see only two columns. See guys. So both ways are fine. You can go with any of the way, but I personally like using this one because it looks very professional in the notebook. Okay. So this is the select statement. Okay. So let me copy paste this select statement and let's now discuss about alias. So alias is like how we can rename the column. If you want to rename the column, this is the function which you can use. So in order to use the alias, all you need to do is just after your column mention dot alias, alias, and then the max temperature. Let's say I want to name this as maximum temperature. Okay. So now I had mentioned the maximum temperature alias for this column. So if I run this one, I should be able to get the data. And see guys, this is how you can rename your column using the alias function. Now let's discuss about the very important function, which is filter function. Filter is a narrow transformation, as you already know. So this is very commonly used function within your notebooks. In order to use the filter function, let's first see the data on which we can filter. Maybe we can say if the rainfall index is, let's say, greater than 5. Okay, let's filter on that. So for that, I will just copy paste my Parquet data frame and I will come here and I will say data frame underscore filter, and I will mention my Parquet data frame, and then I will use dot filter and I will mention the column, and I want to do filter on rainfall column. Okay. And what I want is, I want give me the output where the rainfall index is greater than, let's say, 4.0. So I will also say df filter dot display, and let's try to run this one. Perfect. Perfect. So I got the output where the rainfall index is greater than 4. Okay. So now let's say I want to, filter if the rainfall index is greater than 4, or if the sunshine index is greater than, let's say, 10. Okay. So if any one of the true, I want to filter. So let me go down. So I will say filter using or. Okay, I will say shift plus enter. And here I will just say or you can use or using pipe. And then you will mention the second column, which is sunshine. Yes, yeah, sunshine, small. And then I will mention again, sunshine should be greater than, let's say, 5. Okay. And instead of closing it here, I will remove it and close it here. And this should work. What? Oh. So sunshine column is string column, which is not actually. That's the, disadvantage of using infer schema sometime. So anyway, I had mentioned as a string. So now I got my output. Make sense? So this is how you can use filter using or. And similarly, if you want to use and, you can just tweak here. Instead of pipe, you can just say ampersand, and it will work the same way. Okay. Cool. Perfect. Perfect. So this is pretty much about the filter transformation. We had covered filter transformation, alias transformation, as well as the select transformation. Okay, so let's now understand the another transformation, which is with column rename. Okay. Rename, shift plus enter. This column renames the column inside the data frame. So now you will ask me, Jaswinder, we was also using the alias and alias was also renaming the column. Then why you need with column? So that's what I'm telling you, that with column rename is used to rename the column in your actual data frame, but the alias is you use with the select for just the temporary purposes. Okay, if you have to change the name of the column in the actual data frame, you need to use with column rename function. Okay, So this is the difference between alias and with column rename. Let's try this as well. I will just take this df parquet, and here I will say df renamed is equal to df parquet dot with column rename. And let's say I want to rename column min temperature with minimum underscore temperature. Then I will just say df renamed dot display. And see guys, it worked. So it actually had renamed my column from min temperature to minimum temperature. So this is very useful when you have to rename the data frame. Instead of this df rename, if you mention df parquet only, it will literally rename the column inside this data frame. Okay, so this is how with column rename works. Let's now understand another very important transformation function, which is with column. Before explaining you the with column function, I will go to my read files folder and I will quickly grab another customer CSV data frame, and I will come back to my transformations and I will just run this data frame so that I can use it here. And by the way, you can also do the same thing using magic commands. We will cover that in future. Don't worry. As of now, just paste it. Okay. And then below, I will help you with the with column now. So what exactly is with column? Let me do shift plus enter. With column is a transformation function which we can use to add any new column if you want. If you want to update any kind of existing column, that also you can do with the with column. If you want to change the data type, that also you can do with column. And even if you want to some kind of aggregation or calculations, that also you can do with column. So this is the master transformation function, if I have to say. Let's create one more text and write what exactly it can create. So I will just say first thing, it is used to add a new column. Then it can be used to update an existing column. Then we can use this for change the data type. And then we can also use this to aggregate or perform calculations. So these four things we can literally do with column function. We can add a new column, we can update existing column, we can change the data types, and we can even perform aggregations or calculations. Okay, so let's do one by one. I will start with the aggregations. I have a data frame ready with me. So I will just copy paste this data frame and I will come here and I will say df underscore with, and I will say df dot with column. And first thing what I will do is I will perform the calculation. So in this table, I have first name and last name, and I don't have full name. Let's say I want the full name as well. So what I will do is here I will mention the full name. So I guess this only one code will cover add a new column and aggregate and perform calculation. Okay. So now in order to add the full name, I need to use first name and last name. So in order to concatenate them, I need to use the function called concat. So I will mention the concat function. By the way, there is another function called concat ws. Ws indicates with separator. We will cover that as well. So now I will just the tab, and what is this doing is this is selecting the first name, and there is a literal between the first name, I mean, which is a space. By default it will be added to everything, and then we will be having the last name. And then I will say df with dot display. Let's run this. Perfect, it ran successfully. So at last I should be having the full name. See guys. Okay, so this is how you can add a new column, first one, and perform the aggregations as well on the same time. So now we understood these two. Let's update an existing column. By updating an existing column, I mean renaming the existing column. Okay, so in order to do that, it's very simple. I will just say code and I will just copy paste this code itself here. And let's say I want my first name to be displayed as first underscore name. Okay, so in order to do that, I just need to say here first name and the output should be first underscore name. So now I just ran with column and I passed my new column name and the old column name. And when I ran this, I can see the column is also renamed by first underscore name. But had you noticed that with column is creating a new column even though I am having the existing column? So this is where when you need to use with column renamed instead of with column if you literally want to change the column name in place, else you need to now after this you need to drop the column. Okay, let's now see that how we can change the data type. For that I will go and create a new code template, and here I will mention my column name which is index, and then I want to cast the column index. I will mention index and I will say dot cast as string. Okay, and then I will run this. And see guys, now index is string type. Earlier index was integer type. So this is how you can cast the data type as well using the with column transformation function. So this is very powerful function is very widely used function whenever you are working with PySpark. So please do revise and please do hands-on on using this function. Okay. So as you had understand the with column, and I had already covered the cast as well with the with column itself only. But when you need to use the cast is, let's say you are joining the two tables, okay, and the joining key is order ID. Okay, in the first column the order ID is having the data type as integer, but in the second table order ID is of string type. If you try to join this, it will not be giving you any results, right? So this is where the casting is very helpful, and that's why you should revise casting as well. Okay, there is one more thing which is known as limit. Okay, so I guess you are already aware about what is limit. So you can just say limit 10 or limit 100 based on your requirements. So if you just want to see the subset, I am not covering the limit. Okay, I am just leaving the limit to you guys because this is pretty straightforward. Let's understand the sorting in data frames. I will just add a new text. I will say sorting, and I will there is shift enter. So sorting is sorting, like you are just sorting either in ascending order or descending order. Let's sort this table based on subscription date. Okay, so for that I will just use df underscore sort is equal to df underscore with dot sort, and I will sort based on this subscription date. So I will mention here subscription base date. Perfect. I will run these and it will sort my data based on subscription date, and by default the sorting is in ascending order. If you want to sort it in descending order, you need to mention sort dot descending as well. So let's see first this one. So hey, see guys, so here they had sorted in ascending order. So first is 13, 23. So it had sorted everything in the ascending order. Now, if you want to sort this in the descending order, all you need to do is just mention this as a column. Then here just mention descending and then close this, and this should work. Perfect. It ran successfully. So if we go and see now, this got sorted in descending order. This is how you can sort the things in ascending or descending order. But what if there are a lot of columns? Like let's say there are 3 columns you want to sort on, and let's say the columns are subscription date and then country. Okay, let's say. So in that, I will just go for a new code, and here I will write that code. I will say df underscore sort 2, and then I will say df underscore with, and then I will mention the sort function, and then I will create a list which things I want to sort. So as of now, I want to sort on subscription date and country. If I just run this, it will sort both of the thing in the ascending order. But I want country in ascending order and subscription date in descending order. So how we can do that? I can just say comma, and I will say ascending is equal to, I will create a list and I will say 0 comma 1. I will just run this df sort 2, and here this time I will say display in front. Both are fine. You can even say dot display, or even you can start with display. Anything is fine. So now this got sorted in descending order and my country got sorted in ascending order. So this is how you can sort based on multiple records. Let's now understand another important function, which is drop. So I will just say drop, shift plus enter. And drop is something which you can use as it's a self-explanatory that it is used to drop a column. So let's say I don't want phone number 2. So in order to drop that, all I just need to do is I just need my data frame. I will say df drop and I will mention my data frame and then I will say drop. Which column I need to drop? Then I need to mention the column. So I want to drop phone 2. So I will say phone and 2. And then if I run display df drop, I should not be able to see phone 2. Oops, I had mentioned wrong one. Yeah, so let's run this again. Okay. So now after phone 1, I cannot see phone 2 because I had dropped the phone number 2. So this is how drop works. You can drop any number of columns using this drop function. And there is very similar function to drop, which is known as drop duplicates, which is not relevant to dropping the column, which is relevant to dropping the rows. Okay, so let's discuss that as well. So I will just go down and I will just add a text. I will say drop duplicates, shift plus enter. And now I will drop the duplicates and I will say df dupe1 and I will say just say drop duplicates and then I will say display df underscore dupe1. So it will eventually drop the duplicates based on the entire row. Okay, so if there are two rows which are entirely same, then it will drop the duplicate row. Okay, but let's say your requirement is very different. Your requirement is to drop the row based on few columns. So you have a subset of columns which should be unique. So in that case, you can mention the subset here as well. You can say, let me just say 1, 2, and here also 1 to 2. And then you can mention the subset here. You can just say subset and you can mention the list of columns on the base of which you want to identify the duplicates. Let's say customer ID and country. Okay, let's do that. Let's try that. It's just a demo. Customer ID and then I will say country. Okay, then I will run this one. So this again gave me the same records because there was no duplicates based on customer ID. So I will show you something. Maybe I will remove this country as well and let's see if there are any duplicates getting removed based on customer ID. No. Wow. Wow. So there are literally no duplicates in this data. But yeah, I got it. Maybe let's do duplicates, remove duplicates based on subscription date. Now there will be subscription date. So let's run this. Now the count should be decreased. See, 96. So this is how you can use drop duplicates. Drop is useful to drop the column, whereas drop duplicates is meant for dropping the record, which is duplicate based on either the entire row or based on either the subset. This is how drop and drop duplicates work. Okay, this is very important for interview point of view as well. Okay, please do remember this difference. Let's now try to understand union and union by name. So let me give the heading union and union by name and I will do shift plus enter. And here the union is nothing, it's just combine both the tables, table 1 and table 2, and it will give me the desired output. But if my columns are shuffled between two data frames, then I will use union by name. Let's see this with example. So here I have created two data sets. First is data 1 and second is data 2. And I had created a data frame on top of these two data sets. And let me first display both of the data frames. Here we have ID name and code and ID name and code. And let me insert one more ID. So let me copy paste this ID itself. I will say Control C and Control V. Perfect. So let me rerun this. And it ran successfully. So now what I will do is I will first perform union. Okay, so I will say df underscore union is equal to df1 dot union df2. Then I will say display df underscore union. Okay, so let me comment these two lines. I will say control plus backslash and it will go for a comment, and then let me run this. So now I had ran this and you can see it had simply combined both the data sets in my output. So the reason why I copied the last row here, so that I can show you that it don't care if tables are having duplicate row or not. It will still combine those rows as well. So this is how union works. Let me show you one more example. So here the columns and the rows are same. Just I had shuffled the columns. So instead of code in my data frame 2, first is name, and instead of name it is code. So now I will just say df underscore union try, and I will say df1 dot union with df2. Okay. So then I will display my df union try. Okay. Let me run this now. And see, it had ran, but it had populated the wrong data inside the wrong columns. So this purely shows that union is very blind operation. It will literally combine both of your data frames and give you the desired output. It don't care what is the data type, even the columns are aligned or not. But if instead of union, I had used union by name, union by name, then the story will be very different. Let me run this now and see, guys. You got it? This is the difference between union and union by name. Let's now discuss about the most widely used function in the PySpark, which is date functions. So these functions are something which we literally use every day in every layer. I don't see any room where we don't use these kind of functions. Okay, so let me give a heading first. So I will say date functions, shift plus enter. And now I have data sample written already. So I had included 4 columns, and 3 of them are date and date time column, so that we can understand by using this data frame how we actually work with all kind of date functions available in PySpark. Okay, so I will just run this cell and then I will open a new cell till the time it's running. Okay, and now first thing, let's discuss about very common date functions. Those are current date and time functions. So what I will do is I will directly use select df dot select, and here I will pass current date and I will give this as current date. And then I will say dot show. And then I had ran this one, and this is the first basic one, which is the current date printing. Okay. And similarly, we have another one, which is current timestamp. So I will just say same here, current underscore timestamp. And I will alias this one. And then I will close this bracket, and then I will again run this one. So these are the very basic functions which we can usually use with the audit columns. So if you see here, my current date is coming exactly full, but my current timestamp is coming truncated, right? So I'm not able to see my complete current timestamp. So in order to fix this, all you need to do is you need to say truncate is equal to false and you need to rerun this cell. And that's it, guys. This is also fixed. Next category which I want to cover is date conversion and formatting functions. So let's give this a name, date conversion and formatting. And here also I will just use the above data frame only. I will say df.select, and here I will try to convert my one column using toDate function, and I will pass my column name is date str. Then I will just rename this column, let's say as standard date. So this is the default date conversion because I hadn't mentioned any date format. So it will convert whatever the default date conversion of Databricks is. So let me run this and see. It had created a column with the default date conversion, which is YYYYMMDD. Now let's try to convert into my specific format. For that, I will literally copy paste this one, and here I will change my column name to, let's say, other column. What is the other column I am having? Customer date, let's say. I will copy paste it here. And then I will mention the format. Here I want to convert this into DDMMYY. So I will mention it here. And then I will name this as, let's say, custom date. And yeah, that should be fine. Let me run this. Okay, it worked fine. So you can see the custom date, which was earlier in DDMMYY format. Now it converted into the default Databricks format. The third one is to timestamp. And here I will mention my timestamp column and I will name this as, let's say, standard timestamp only. And then now let's run this. And now I got my standard timestamp as well. Okay, now I want to know the day as well. Okay, so in order to know the day, I will again use date format, and here inside this, first thing I will mention my date column and then I will pass my format. So here I want the day, so I will be saying 4 is, and then I will say comma, and then I want month in 4 words, then I want dd, and let's say I want this only. Okay, so I will name this as, let's say, verbose format, let's say verbose format, and then now let's try to run this and see, guys, it is giving me date and as well as my day. These are my date conversion and formatting functions. Okay, we have to date, we have date format, we have to timestamp, and based on your requirement you can tweak inside the date format. Next category is date arithmetic and extraction. Date arithmetic and extraction. Perfect. Shift plus enter. And here also I will use again df.select, and now the first arithmetic extraction function I want to use is date add, and I will mention my column name. I know it's recommending me to do things, but I will write my own code so that I can literally help you to understand in better way, because I am adding 10 days in my current date. I am renaming this column as, let's say, plus 10 days. And then at last I will mention show truncate is equal to false. Let's run this. Perfect. So I got my plus 10 days. Similarly, I can do the same for minus 10 days. I will just copy paste this one till here, Control C, and I will add a comma, and here I will paste this, and I will, instead of date add, I will say date sub, which means subtract the number of days. And let's say I want to subtract 5 days. So it will be minus 5 days. Let me change this, minus 5 days. So let's run this as well. Perfect. See, guys. Okay. Now I want the difference between the dates. Okay. How many days are coming between two dates? So in order to do that, we have a function called date difference, and then we mention two columns from which we want to extract the date difference. First column should be the highest value and second column should be the minimum value. Okay, let me write something. I will say current date, and then I will say my other column, which is date str. I will mention it here. I will name this column as dot alias days difference. Okay, and let's run this and see, guys. So it is giving me the date difference between my current date and my date str, which is mentioned in my data frame. Okay, but what if I reverse this? Let's do that as well. I will just copy paste my complete string down here, and I will remove this part, and then I will add this. Then I will run this again. Oops, it will not run. Okay, it ran even with my comma. Okay, that's fine. But yeah, now see, guys. So if I mention the minimum date first and maximum date after, then it will give me the date difference in minus. Okay, so that's the reason I mentioned that in date difference, first thing you need to mention is the latest date, and second thing is you need to mention the other date. Okay, now date difference is also covered, and let's discuss about add months. Yeah, this is also very important one. How many months you want to add? So let's say I again use the same column date str. I want to add, let's say 3 months. Then I will say dot alias plus 3 months, and then let's run this as well. And perfect. So it had added 3 months in my date str column. I'm thinking why I'm not printing the date str as well. I should print that as well, right? So I will just say column date str. Yeah. So you can see that this is my existing date, and after adding the 3 months, this is coming. And after adding the 10 days, this is coming. So it actually makes more sense if I had added the date str in the first column, but that's fine. I guess you got my point. Okay. Last function in this category of date arithmetic and extraction is months between. Months between, again, it will calculate the months between the two dates. So here I will just mention whatever it's mentioned here, current date and my date str, and I will name this as months between, and let's run this as well. And see, guys, so it had given me the months between the current date and my date str. This is how you can work with date arithmetic and extraction functions. Next category is date component extraction. Let's give that heading as well, date component extractions. So this means to extract the day or month or year from the specific date. Okay, let's again say df.select and try to extract year from my, let's say, date str only, and I will name this as year, and then I will say dot show truncate is equal to false. By default truncate is true, but if you say truncate is equal to false, it will actually show you the complete output. So the year is 2026. Okay. So now I will not do the same mistake which I had done in the previous. First column I will pull is date str only. It will avoid any kind of confusions. Yes, now this is fine. You can understand from this that this is my original date, and inside my original date year is 2026. So it has successfully extracted the year from this date. Next function which I want to show you is quarter function. So if you want to calculate the quarter, which quarter you are in, so you can say quarter, and then you can use that again the column date str, and let's name this as quarter, and let's run this. So I got the quarter because it, in my year we have 4 quarters, so it, this date sits in the first quarter, so it is saying quarter is 1. Let's also find the month. So I will say month of this date str, and then I will name this as month, and let's run this. And my month is also first month, it's January. And then next one is day of month. This is also self-explanatory, day of month. I will just mention my column, and then I will just rename this. Perfect, it should be fine. See, so it is giving me the 15th January as the day of the month. And let's say you also want to find the day of the week. Day of week, you can mention again here the date str, and then you can mention the alias day of week, and let's run this as well. So I got my day of week for 15th of January. The day of week is 5th day of the week. We can also do the same day of year and week of the year. Let me quickly do both. day of year, and then I will mention my column, and then I will say alias. And similarly, I will do the same thing for week of year, and I will mention my column name, which is date str, and then I will say alias week of year. And these all are data component extract. Now I will run all these and you can clearly see that how we can extract the date component from a column. Based on our requirement, we can extract year, quarter, month, day of week. It is very helpful when we are actually calculating the holiday logics. And the last category is boundary, truncate, and advanced kind of, let's say, dates. So you can say boundary, truncations, and advanced logics, shift plus enter. And here also, again, I will just repeat myself, df.select. And first thing I will calculate here last day from this date str, and I will name this as end of month day. And then I will just say dot show truncate is equal to false. And I can see that for this date str, my last day of month is 31st of January, which is true. Next is the next day function. I guess you got what is next day. So I will just mention here next day, and I won't explain this because it's self-explanatory. Yeah, and I will say alias next day. And then similarly, I can even truncate the date to only extract the year. I can even say truncate this date str and extract the year from my truncated date, or either month call also we can extract, but let's extract the year. And I will just name this column as truncated year. Okay. And then the last one, you can even do the date truncate as well. So you can say date truncate, and you can mention on what basis you want to truncate. Let's say this time I want to truncate based on hours. So you can mention the column. Let's say I will also change the column this time. I will say timestamp str, because timestamp str column is having the timestamp as well. So it will be actually making sense using this column. And then I will say truncated hour. Oops. So I will just remove these things. Just run this complete cell. Oh, I forget to put the next day which I want to extract. Next day, expect two variables. First is the column name and second is the next day which you want to. Let's say I'm on Thursday, I want to calculate the next Sunday. So you need to mention that here as well. So the next day, Sunday, is 18th. Truncated year, 1st January 2026. Truncated hour is this one. So this is how it calculates truncations and boundary logics. Okay. So this is pretty much about date functions, and these functions are very, very widely used, and you will literally be using them on a regular basis. So please do practice them as well. Let's now discuss about the string functions, and let's give this a heading: string functions. This is a very long topic because there are a lot of string functions to cover. I had already written the script to create the data frame, as well as I had already written the type of string functions. So we will go one by one. So first thing first, I will just run this data frame. And it had ran successfully. So now the first type of string functions we have is case, conversion, and length functions. So I had created a data frame and I had mentioned df.select. And then first I am just literally taking the reference of my original column, because last time I did that mistake. So it was not looking good. So I had taken the reference of my original column. And then what I had done is I had used the dot lower function, okay, on that column, and I had named that column as lower column. Similarly, I had mentioned the upper function, and I guess you understand what dot lower and dot upper function will do, right? And then third function I had mentioned is init cap. What it does is it capitalizes the first character of every word, and the fourth is length. Length is length. It will just calculate the length of the string. So let's display this function. I will say display df underscore case. Let's run this. So this is known as case conversions and length. Okay. So once this runs, you will be able to see the beautiful result with the 5 columns. First is raw text. This is my raw text. And if I do the lower, everything will go in lowercase. If I do upper, everything will go in uppercase. If I do init cap, the first character of the word will be going into the capital case and rest all will be in the lower case, and then the length. I guess that's pretty much self-explanatory how we can work with case conversions and length. These functions are very helpful, especially lower and upper, because whenever you are doing join, it's the best practice to convert the joining keys either to lower or upper so that it matches the conditions. Okay. And the length is also very helpful. So these all are very helpful. I'm not saying only length is helpful or upper is helpful, but these functions are widely used in the industry. Okay, these type of string functions are known as case conversions. Okay, next type of string functions are trimming and white space removal. Okay, and here I am creating a new column clean. Okay, and what I am doing, I am trimming my existing column raw text. So we will use this helper column clean to run all the subsequent things. Okay, so what I had done is I had used this helper data frame clean, and I had first obviously select the as it is original column, and then I had done L trim. L trim means trim all the spaces which are on the left, and R trim indicates trim all the spaces which are on right. Okay, and then at last I am literally printing the clean column. So if I just try to display this one, display df underscore trim, I should not be able to see any kind of spaces, either leading or lagging. So see guys, so this is how trim function works. Here you cannot see because there are actually no spaces in the raw text. If there was spaces, it will be trimming the spaces. So this is how we can work with trimming and white space removal functions. Third type of functions are concatenation and splitting function. And concatenation functions you had already seen in my past videos. And I guess you already know that concat merges the string without the separator, and concat underscore ws indicates with the separator, it merges the string with the separator. This first function requires two parameter, and this second function requires the two parameters, and we had already explored concat and concat underscore ws, and you know how this works. So here what I am doing is I am using my clean column which I had created up, and then I am patching a literal developer with this. Okay, and then I am naming this as concat, and similarly I am using the separator pipe, and then I am trying to attach the clean and the code column, and I am giving this column alias as concat ws. And the third is split. What split do is it will split your sentence based on the separator. In this case the separator is comma, and it will create the array for that. Let me show you quickly. I will say display df concat split. Let's run this. See guys, this is what I was talking. Concat and concat ws you are already aware. And the split, what it does is based on the separator, it splits the sentence and it creates the array. This is all about concatenation and splitting functions. The next type of string functions are substring and extraction functions. And substring extract the substring based on the past parameter from starting to the ending. And the substring index extracts the substring relative to a specific delimiter. Okay, I will show you how this works, and let's do that. Let's run this. If I pass +2, it will show me the index before. If I pass -1, it will show me the index after. So let me run this df underscore substring display as well. And here you can clearly see the substring index. This is how you can work with substring and extraction. We cannot remember everything, so you can obviously go to PySpark documentation and copy paste the template from there into your Databricks, or you can even use any kind of GPT models. But you should at least know that where you need to use which function. If you at least know that where you need to use substring, where you need to use substring index, where you need to use concat ws, you are sorted. You can do your work. All you need to do is go to documentation or go to GPT and grab the code and just get your work done. Okay. So these are all about substring extractions. Next one is search and matching. This again is very, 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 very important, guys. And this literally is very important. We use these things on very, very regular basis. Doesn't matter you are developing the things or you are testing it. These searching and matching things are the backbone of the string functions. Okay. So now, first thing first, I had just printed my original column, and then I am using the contains function. So what this function will do, it will check my existing string, and if the string contains the data word, it will say true. And if the string is not containing the data word, it will say false. Okay. So it's kind of the Boolean representation. Next is starts with. It checks whether the existing sentence starts with my specific words or not. So if the sentence in this case starts with data, it will say okay. But if it is not, it will say false. Similarly, ends with also do the same thing. And then we have INSTR. INSTR gives me the index of the first occurrence of the word. So let's say I have a big sentence, and wherever the first time in the complete sentence science is coming, it will give me the index of the first occurrence. Okay. So this is known as INSTR. And then we have locate. It will also do the same thing, but we can mention the optional start, like in this case, learning, and it will locate the word from that index. Okay, now let's try to run this as well. I will say display df underscore search, and let's run this. Oh, underscore. I had put hyphen. Yes. So see guys. So start with true, false. It returned based on the required parameters, right? This is how you can actually use the string and magic functions. Last one in the string function category is padding and replacement. And regex replace and replace are most widely used. rpad and lpad I personally never used much in my development. I used replace and regex replace, and these are most important one. So regex replace will replace the string based on the regular impression which I pass. Okay. And the replace will simply replace the occurrence of that specific string. Okay. So let's run this as well. I will say dot display, and I will hit run. So see guys. So whenever there is a keyword data, it is replacing that with big data. So it had already done that. Instead of data, it had replaced the data with big data. This is how replace works. And then regex replace had checked the occurrence of A to Z in lowercase. So wherever there was a lowercase A to Z, it had replaced that with star. So that's the intentional I had used A to Z. In normal production, you won't be using A to Z. We will be using regex replace to remove the special characters usually. But you should know that here I am using A to Z, and I am replacing all the lower A to Z with star. And you can clearly see that this worked, right? And then I had done the left padding with the width of 20. So you can see the result of left pad, and the complete string length will be 20. Similarly, I had done the right padding as well with the width of 20, and complete string length will be 20. This is how we work with padding and replacement, and that covers the complete string functions. Do practice them 1 or 2 times, you will be good. And whenever you get stuck, just go to the PySpark documentation and grab the required function and get your work done. So these are very widely used functions, and that's why I feel it is very important for me to explain you type of string functions we have in PySpark. So PySpark library is very vast, and you can clearly see what I am talking here. Let's now discuss about another very important function, which is DropNa function. This is very helpful function when you have to drop null values. So let's give the heading. Let's say drop NA, and I will also cover fill NA. I will do shift plus enter. And this is the data set which I had already prepared in order to save your time. Here I have a complete data for one row with only one null, third row with two nulls, and fourth row complete null. So I will just run this, and it started running. Perfect. And I am able to see data inside my data frame. So first thing first, I will show you how drop NA work. So for that, I will say df underscore drop, and I will just say df dot drop NA. I will not say anything else. I will just say this, and I will just display this. That's it. Let's see what it gives. So before I run this one, what actually DropNA will do is it will drop the entire record wherever if the DropNA will see even a single null. Drops any row with having at least one null. So this is how journal drop NA works. So it will drop any row which is having at least one null. So in this case, it will drop this one, it will drop this one also, and it will drop this one also. And my final output will be having only one record, right? So let's run this now. And see guys, as I just discussed, so drop NA, if you just mention drop NA, it will drop any record with at least one null. So usually we never use drop NA, we use drop NA with some subsets of column. Internally, drop NA uses a thing which is called how is equal to any. This is the default behavior. This default behavior only indicates that if in a record I am finding any number of nulls, even a single or even a 100 or even a 10 lakh, I am going to drop that record. So this is the default behavior. I will run this as well and it will show me exactly the same output as I was able to see earlier. Now, if I want to drop a record which is having all the complete entry as null, okay, complete entry is null. So in that case, I will just copy paste this one again and I will just change a behavior where I will say instead of any all. So what now will happen inside this data set, it will only drop that records which whole entry is null. So in this data set, it will only drop the last record because last record is total null, right? So I will now run this and I will show you the output for this as well and see guys. Make sense? The third one is we can mention the subset. Okay, so I will again just copy paste this one. I will come down and here we can also mention the subset as a list form. Okay, let's say I want to drop the column if age and city both are null. Okay, so in that case, I will mention in this subset that hey, if age and city both are nulls, then also drop the record. So in this case, now this record will also go out. Output will only be having two records, right? Let's run this. See guys, perfect, perfect. Now, as I had mentioned, how is equal to all, and as you know, the default behavior is how is equal to any. And if I mention here any, it will delete the record if either age or city or both are null. So in that case, I will also lose Bob as well. So you need to ensure that whenever you are using drop NA function, it's a good practice to always add how as well. Specifically when we have to use and, it's recommended to use how. We have one more. Instead of having how, you can even mention thresh as well. Thresh is equal to, let's say, 2. So what this indicates is in a complete record, I am finding two nulls, then drop that record. Okay. So in any scenario, when in my table I am having two or more nulls, those records will be getting deleted. So if I pass 2, it will be 2. If I pass 20, it will be 20. So let's run this now. So the output in this case, if I go to my source table, should be Alice and Bob, right? Let's see that if this is true or not and see guys, this is true. Make sense? Perfect, perfect. Let's try with one as well. So I will just rerun it. In this time, I will get Alice, Bob, and Tom. Okay, and let's try 3 as well. In this case, I will only get Alice. See guys, this is how you can utilize thresh function as well. If you don't know the subsets, if you know the subset, that's the best thing to do here. And you now know how you can use drop function to get your work done. Okay. And his similar brother is FillNa. So let's try to code that as well. Here, instead of my drop NA, I will say FillNa. And before all those things, I will just rerun my existing data set so that I get back original data. Now I will say I want to fill the null records with, let's say, my name, Jaswinder. Okay, let's run this. So what do you think will be the output? Here, fill NA will go to name column. Okay, let's go to the above data set. This is not good one. Yeah. Here, fill NA will go to name column, and wherever it will see null, it will say Jaswinder. Okay. Here, when it goes to age column, it will never update anything in the age column. Why? Because Jaswinder is a string, not an integer. So age is an integer. So it will skip the age column, then it will go to city column. City column is again the string column. Again, it will update null to Jaswinder and null to Jaswinder. So output is very clear to us. Now let's see what exactly the output we got. And see guys, this is exactly what we was looking for. Make sense? Perfect, perfect. So Jaswinder, this is a very basic table. We understood that we can use fill NA, and if I want to use the fill NA for integer, I need to mention the integer. We are good with that. But in the real world, my table will not be having 3 or 4 columns. It might be having 100 columns or 120 columns. Then how we can manage with this fill NA? How Jaswinder, how we can do that? Don't worry, PySpark had given that option as well. For that, we will just define the unique fillers using JSON format. So I will say fill rules and I will say equal, then I will define my JSON. So let's say wherever there is a name, I want the name to be filled with Jaswinder. Wherever there is a age, I want to fill the age with, let's say, default age, let's say 100. Okay. And wherever there is a city, I want to fill the default city as Pune. And these rules I will pass inside the fill NA. Let me show you the magic. I will just grab this one again here and I will just do some enters. And here I will remove my name and I will say fill the rules. Perfect. And let me run this now. Now you will see magic. See guys. Jaswinder is also there, age is also there, and Pune is also there. This is how you can utilize fill NA function when you are literally working in your project. Because I know in project you will not be having a small table or a few column table. You might be working on a very huge table. So this is the way we can fill the default values in the respective columns. Let's now understand the next important function, which is split and index. I will give a heading split and indexing and I will say shift plus enter. I have a data set. So first I will go is I will just click on this code and I will paste my data set and I will run this data set. Perfect. I had ran the data set. Now what I want is I want to split the full name column into first name and last name. Okay. So in order to do that, I will again go to next code and I will say df_sp, let's say, and I will say df split dot with column, which column I want to be created. I want to create first name. So I will say first name. Let me capitalize. I will say that please split my full name. I will add my column, which is full underscore name on the basis of hyphen. And if I just run this one, I will be able to see the array, which we had just seen earlier as well. So I will again show you. Let's see that. It will all hardly take a minute. df.display. I am running this and you will be able to see the split is not defined. Ah, okay. I hadn't imported the library of the split. So let me go to my very first tab and let me run this tab. Perfect. It is running. It ran successfully. Now I will come back. Here I will just try to rerun this now. And see guys, as I just told you, if I just mention the split, it will create a array. But do I want array for first name? No. I literally want the first name. So how we can do that? I will simply come here and I will simply say that only give me the output based on my zeroth index. So in this case, the zeroth index will be zone. Let me run this now. And see guys, now I got the perfect first name. Similarly, I will copy paste this one complete. I will add a backslash. I will go to next tab and I will paste this again. And instead of first name, I will say last name. And I will just replace 0 with 1. And that's how I fetch the first name and last name from this data frame. And I forget dot. And so that I need to just rerun it. So perfect. See guys, this is how you can work with split and indexing function. If you have to split a column into multiple columns, you can use this function and it is very helpful when you have to extract some subset of data from a column. Okay, perfect. Let's now understand another important function, which is explode. What explode do is, let me grab one more text. So let's say you have an array of integer 1, 2, 3 as a data in a column. Let's say column name is order ID. So a single person can order multiple things, right? So in the single person order ID, I am having, let's say, this thing 1, 2, 3. If I use the explode function, what it will do is it will create 3 records for that. So let's say the customer ID was 1. So first record will be 1 to 1, then 1 to 2, and then 1 to 3. So this is how explode function works. Let me delete this one and let me grab the data set to show you what I meant. This is my data set. So I will just run this data set and this is my existing data set. As you can see, the person Alice knows Python and SQL. Bob knows Java, Scala and C++, and Charlie knows nothing. So if I use the explode function, what I will get is I will get 2 entries of Alice. As of now, it's only 1 entry. But if I use the explode function, it will explode. It will add entries based on the array. So the first entry will be Alice Python and second entry will be Alice SQL. Then again, the first entry of Bob will be Bob Java, then Bob Scala, and then Bob C++. But Charlie is not having any array. So it will keep the Charlie because we will be exploding on the language and language is none. So Charlie entry will be getting skipped. Let's see this in action. Here only I will, let's say, add exploded df and I will say df dot select and then I will select my column name. Now I will here use explode function. I will say explode and I want to explode based on obviously languages. So I will pass those and I will run this now. And see guys, now the output is instead of 1 record of Alice, I am having 2 records. Instead of 1 record for Bob, I am having 3 records. But Charlie was having array as empty, so Charlie got discarded from my final output. This is how explode function works. Similar kind of function we have is array contains. So let's cover that here as well. So I will say array contains, and what it does is, I guess it's self-explanatory. If the array is containing the specific word which I am passing, it will say true, else it will say false. So let's add here only. I will say comma array underscore contains, and I will pass the languages here. So I will say df dot languages and I want to check if in the languages array Python is present or not. Okay, so now if I run this, I should be able to see the 3 columns and the third column will be having values of true or false. See guys, this is what I meant. Make sense? Let's now understand the group by and filter. Let's give a heading quickly. By and filter. I will say shift plus enter and I had created a data set. But first, I believe you already know what is group by. Group by groups the rows with identical values based on the specific columns. And the filter works same as the where clause in SQL. And group by also work as the same actually, but I'm just giving you the definition that what exactly is group by, who just want to just get the definition. So now let's implement this quickly. I guess this will be very quick one. And if you had seen my previous video, you know that group by is a wide transformation. So it impacts the query performance, right? And let's see how we can implement group by and filter using PySpark. So I will just run this below cell. And I have a name, department, state, salary, and bonus. So let's say I want to find the department where total salary is more than 8,000. Okay. So this is something which we can only achieve using group by, right? So let's implement that. I will say df dot group by. I want to group by department. I will add department. Then I have to use aggregate function. Inside aggregate, I want sum of salary, and I will name this as Alias total salary. This is how I had implemented the group by. Now I will also implement the filter. I will say dot filter, and I want to filter on this very column which I just had created, which is total salary should be greater than 8,000. And I will just add dot show as well at last. And see guys, I got the result of the departments where the department wise total salary is more than 8,000. This is how you can use group by and filter, and this is very straightforward as you already know SQL, so there should not be any kind of trouble using group by and filters. Next up function is approx count distinct. Let me add the text approx count distinct, shift plus enter. This PySpark function is used to estimate the number of unique values in the column. This uses hyperlog algorithm, which is nothing, it's just a data structure which estimates the cardinality of any table by using exceptionally small fixed amount of memory. So that is known as hyperlog log algorithm. Let's write down here as well. This function is used to estimate number of unique values in a column. This uses hyperlog log algorithm, which is nothing, just a algorithm used to estimate cardinality using exceptionally small or fixed amount of memory. Okay, so this is what we call approx count distinct. Okay, let's take a data set and do this hands-on as well. I had copy pasted my data sets with two columns, item and category, and I am going to create a data frame on top of my data. And perfect, data frame is successfully created. Now let's calculate the approx count distinct. I will just grab another code and I will say df dot select approx count distinct, and I will add my column, which is item column here. And then I will say dot alias. I will name this as approx count, and then I will say dot show. And let's run this. See guys, so it had given me approx count. It hadn't given me the exact count. It had given me just the high level approx count. So this is the function. Here we have one more parameter which is known as RSD. RSD means relative standard deviation. By default, it is 0.05. This means allowed percentage of error is 5%. Okay, and you can tweak it to 1 or 2, whatever. So let's tweak it to 0.01. So this way you can add this value based on the accuracy level which you want. Okay, so this is how we can work with approx count distinct function. Let's now discuss about another important function, which is collect list. Let me give a heading, collect underscore list, and let me do shift plus enter. Collect list is exactly reverse of explode function. In explode, where we take the array and convert that into multiple records, in collect list, we take the multiple records based on the group by and we combine them into an array. Okay, let's see that in action. I will quickly create one data set. I will say control plus enter. Perfect. It had ran successfully. Now I will create another data frame. I will say, let's say result df, and I will say df dot group by, and I will group by based on employee. I will just copy paste. And then I need to provide aggregation as well, right? Aggregation of collect underscore list. And on top of which column I need to aggregate? I need to aggregate on top of project column, right? So I will just mention the project column here, and then I will give this column alias as, let's say, collect list column, and then I will just say result df dot display. Let's now run this and see guys, Alice was having, let me also display this one as well, df.display. I will show you both in parallel. See, Alice was having 3 entry, Project Alpha, Project Gamma, and Project Alpha, while Bob is having 2 entries, Project Beta and Project Delta. So that's why, because I grouped by on employees, it gave me 2 records in the output, which is Alice and Bob, and the respective array list as well. Okay, this is how you can use collect list, which is exactly the reverse of the explode function. Let's now discuss about pivoting and unpivoting. So let me give a heading, pivoting and unpivoting. So pivoting means converting the records into columns, and unpivoting means converting the columns into records. So both are reverse of each other's. Okay, let's try to implement them as well. This is my data frame. Let me run this sample data frame for you guys. So now, as I had ran the sample data frame, I will first apply the pivoting. Let's say I want to pivot the country column into the new heading. So what I want is, I want product, and then second column I want is USA, and the third column I want is Canada. In order to implement that, I will create a new pivot data frame, and I will say df.groupBy, and I will be needing product column. So I will group by product, and then I need to mention the pivot function, and on which column I want to pivot. I want to pivot on country column. Okay, makes sense. So Jaswinder, you are doing group by, you also need to do aggregation. So this means we need to aggregate based on amount. Yeah, sure. Sum of amount. And let's try to show pivot. And see guys, so I had converted records into columns. Unpivot is the reverse of this. Let's try to implement unpivot on top of this pivot data frame. I will say unpivot data frame is equal to pivot data frame, and this time please take notes. This one is very, very important to understand unpivot, because this is different than pivoting or applying any other transformations. So you have to understand this very closely. Okay, what I am going to do. So I had taken my pivot data frame, and first thing, obviously I will just do select, and I will select the product column, because product column is available as it is in my original one, right? So once I mention the product column, I will say EXPR. What is this EXPR? EXPR indicates expression which allows you to write the SQL-like logic inside the PySpark. Okay? So this is nothing more than an expression which allows you to write the SQL code. Okay? So now inside the EXPR, start double quotes, and I will mention stack. Now what is this stack, Jaswinder? We never hear about the term stack. What is this? Basically, Spark does not support natively unpivoting. So in order to help you in unpivoting, they had introduced expression, and inside the expression they had introduced a keyword called stack, which will help the data frame to understand that, hey, I need to unpivot this data. So now in stack, I will open and close the bracket, and here inside this, I need to mention how many columns I want to create. In my case, I want to create 2 columns, because in my existing data, I was having 2 columns, country and amount. So I will mention 2. Then it will ask me that on which records I want to create. In my case here, the records are USA and Canada. In pivoting, I created 2 columns, name USA and Canada. So I need to mention these columns here inside my expression. So first thing, I will mention the literal Canada, which indicates the value. And second thing, I will just mention the Canada, which indicates the column. Similarly, I will do for the USA. And once this is done, I just need to rename the column. I will say as, and what was the existing column name? Country and amount. So I will just pass here country amount. And then I will say unpivot df.show. And this should work. Perfect, guys. So see, so it had successfully unpivoted the data as it was original. This is how you can utilize pivoting and unpivoting function. Unpivoting is very different, so obviously you need to practice unpivoting couple of times. The easy way to do is just remember that whenever you are doing unpivoting, you just need to mention the expression function, because there is no unpivot function. In pivot, we have dot pivot function, so automatically everything is getting handled. But for unpivoting, you need to mention the expression. On top of that, it will unpivot the data. Okay, let's now understand when and otherwise. So if you had worked with the SQL, you already know when and otherwise is very similar to case when statements. In the Python language, it is very similar to if else. Implementing this is even more easier. I will show you. So first thing, I will just create a data set. Okay, I have a data set where I have name of the people, their gender and their salaries. And I will just run this data frame. I had ran this data frame and now I will implement my when otherwise. Let's create the code for a scenario where gender is male and salary is less than some specific amount. I will just say df bonus, df tot with column. I will create a new column. I will say bonus eligible, and then I will start when and otherwise now. So okay, what I will do is I will say when, and my column is gender and that is equal to female, and column salary is greater than 50,000. Then I will say eligible for additional bonus. And then I will say dot when column is gender is equal to male and my column salary is greater than 45,000. Then I will say eligible for additional bonus plus candy. Okay, let's do that. Okay, if that's not the case, then it will go to otherwise. So I will say dot otherwise. Thanks for your contribution. And let's try to run this one. I know you are thinking about context. Don't think about context. Just focus on the function. Oh, so yeah, I had just beautified it. It looks good. So let's try to run this. It looks promising. Yeah, great. Great. So we are done with when otherwise as well. This is how you can implement when and otherwise PySpark functions. Okay, next up is joins. So here we will be covering all the kind of joins: inner join, outer join, left join, right join, anti join, except broadcast join. We will be covering every join in this transformation lesson. Broadcast join we will be covering in future lesson. Okay, so now let's start with the join. So I have a data set of employee and department, and I will just run both of the data sets. And I can see employee data frame as well as my department's data frame ready there sitting. So it's the time to start with joins. Let's start with inner join. And I guess you already know pretty much about joins. I will just give a little bit of inputs. Okay, I will not be going in depth what is inner join, what is left join, because I know that you already know that. So let's create a data frame. Let's say inner data frame. And then I will use employees table. Yeah, employees table. I will copy paste here. And I will say employees dot join, and I will mention another table which is departments table, and then I will add comma and I will apply the join. I will say from employee table, from employees table, take the department ID. Do I have underscore? Yeah, we have underscore. Okay. So from employee table, take the department ID and join this with my departments tables department ID. This is the second parameter which we pass. First parameter is my joining table. Second parameter is my joining condition. And the third parameter is a kind of join. In this case, the join type is inner. So I will mention inner. And let's say inner dot show as well. And let's try to run this. So this is the output of the inner join. Okay. So that's all. Inner join gives common output from both the tables. And next one is left join. And left join gives the output all the records from my main table and matching records from my child table. Okay, so let me copy paste this one only and I will just paste it here. And instead of inner, I will say left, and here also I will just say left. And then I will join employees and everything looks good. I just need to change here left and I will just run this. Similarly for right, it will take all the records from the department table and the matching records from the left table. Let's implement full outer join. I am not going to implement right join. I'm leaving it to you. So I will say full outer join, shift plus enter, and then I will copy paste my inner df, and here I will say inner outer, and here also I will say outer, and then here I will just say outer. And that's it, guys. I will just run this. So outer join includes all the records from department as well as employee. If there are unmatched records, it will populate nulls. Okay, this is how full outer join works. Let's now discuss about the most confusing and interviewer favorite type of join, which is left semi and left anti. I will add one more text to explain about left semi. So what is left semi? Left semi will give you records from left data frame which are matching with right data frame. Okay, in my case, right data frame is department. But Jaswinder, isn't it same like a left join? Yeah, if I will say till this point, it is same till left join. But now I am going to add more context to this. I will say, but it completely ignores the right table columns. Now make sense? This is why left semi join is different from left join. Okay, now let's talk about left anti. It is actually reverse of the above. I will just copy paste the above one here and I will say it gives you record from the left join which are not matching with the right table. Okay, but it completely ignores the right table columns. Now makes sense? This is very, very important and it is literally asked in the interviews. I even faced this question multiple times. What is the difference between left semi and left anti? This is very important to understand. Okay, so that's why I had written down definition here. It's the time to implement both of them. So I will just copy paste the above one data frame here again and I will just change my data frame name to, let's say, semi data frame, and here also I will pass semi data frame and here also I will pass left underscore semi. Okay. And that's it, guys. Let me run this now. And see, guys, it had only given me records from my left table. My left table is having employee ID, name and department ID. Let me show you my left table. See, my left table is only having employee ID, name and department ID. Although other tables, if you see inner, it had shown me department ID and department name. And let me go to left. See, guys, let me grab this notebook to below. For that, I will say move down. And I will move more down. I will align this with my left semi so that it will be easy for you to understand. I will again go down where move down. And then here I will again take one more step to move down. And then again down. Yeah. Now this is fine. Now you can clearly see. This is my left join and the output was all the columns from the left table and all the columns from the right table. But this is my left semi and the output is only from my left table. Now I guess it makes sense, right? So in this case, if you see, as the output was both from left and right, when there was nothing in the right table, it had done null, but this one excluded those entries. If you see David and Eva was null, here we even don't have the David and Eva. So this is exactly the definition of left semi. It gives you record from the left data frame, which are matching with the right data frame. This is fine, but it completely ignores the right table columns. Okay, this actually makes the difference between left and left semi. Okay, now let's implement left anti as well. We just copy paste this one below only. And yeah, and then I will say instead of semi anti, here also I will say anti. And then here also I will say left anti. Perfect. Let me show you now. So as per the definition, it will give you the records from the left data frame. This means in the output, we will be having 3 columns. Okay. But it completely ignores the right column and it will give me not matching. So here I got matching records, but now in left anti, I should be getting David and Eva as the output. See, guys, David and Eva is the output for the below. This is how you can work with left anti, left semi and left join. It is very important to understand at least this one. Okay. With that said, we had again covered the joins as well. You have access to all of these notebooks inside my GitHub. You can literally download and tweak and try understanding all of these things. Okay. Let's now discuss about window functions. Before moving to the Databricks, I want to discuss about the 5 type of window functions, which are row number, dense rank, rank, lag, and lead. So let's discuss about these functions one by one by starting with the row number function. So what row number do is, if I do partition by, let's say, department, let me write it down here. If I do partition by department, the row number will return here 1, then 2, then 3. Okay, so basically row number always return the value in the increasing order. Similarly for sales, here also it will say 1, 2, 3, 4, 5. Even though the values of these are same, still it will just print the incremental number. So this is how row number works. So whenever you have to index the data based on partition, you can use row number function. Now, what about dense rank? Dense rank means literally dense rank. Okay, I will show you what I mean. Let's say I partition by department, and let's say I am ordering by salary. And in that case, obviously by default, if I order, it will be ascending order. So the first dense rank for 1200 is 1. But if you notice, in IT department, there are 2 people whose salary is same. So in that case, both of them will get 2. Similarly, first it will get 1. Now 3 are having the same salary. So all these 3 will be ranked as 2. And now the last one is having different salary. It will be ranked as 3. This is how dense rank work. Okay, now let's see how rank works. Do partition by department, order by date. The first here, it will be obviously 1, but the second here, it will be 2, right? And here also it will be 2 because of the same value. Okay, now let's talk about sales. Here also first one will be 1. Now these 3 will all be 2, 2, 2, 2, but this one will not be 3. This one will be 5. Because if you see, its row number is very aligned with the rank. So this is how rank, dense rank, and row number works. So rank skips the index based on the similar values. Okay, in this case, it had literally skipped 3 and 4 because 3 and 4 was occupied by 2. And dense rank means it will not skip the 3 and 4. So this is how we work with the rank, dense rank, and row number. Now let's discuss about lag. So if you see here, lag means before the current value, right? So here, first value is 1200. So is there any value before 1200? No, right? So here the first will be null. For second, it will be 1200. For third, it will be 1290. But when I move to fourth, I am literally changing the partition. So it will again start. Before 1300, do I have anything? No. So it will say null. Then before 1500, which is 1300, it will print 1300. And similarly, before 1500, it is 1500, 1500. And then again here 1500, and then again here 1500. This is how lag works. And lead is literally reverse of that. Lead means the next occurring number. Here the first value will be 1290, then it again will be 1290, and partition ends here, so it will go null. Similarly, here also it will go 1500, 1500, 1500, and then the next partition is 16, then the next value is 1690, and then the last will be null. So this is how lag, lead, rank, dense rank, and row number works. Make sense? Let's implement them one by one in PySpark now. I will name this as window functions, and I will say shift plus enter. And this is the data set which I had created. I had already ran, but let me rerun this. Perfect. And now I will add another code, and I will add one more text saying that below code is for row number, rank, and dense rank. First thing is I need to define a window specification. For that, I will create a variable window spec, and I will say window dot partition by, and here I will mention the column. In this case, my column will be department. So I will mention here department, and then dot order by, and on what basis I want to order, on basis of salary. So I will say, let's say salary should be in descending order. And this is how I had specified the variable which is window spec. Now I will use this specification in my select statement. I will say df.select, and I will pull all the columns like name, department, salary. So I will say name, department, and then salary, and then row number dot over, copy paste this inside the over, and I will say dot alias, and I will name this as row num, let's say. Similarly, I will calculate rank and dense rank. I will just copy paste this template and I will paste below 2 times. First thing, I will just change here to rank, and then I will say here RNK. Similarly, here I will change this to dense underscore RANK, and here I will say DRNK. Perfect. And now I will just add dot show, and I will run this one. See guys, this is how rank, dense rank, and row number works. And I guess if you are from data engineering background, you should be knowing how we work with rank, dense rank, and row number function, because these are the foundation of SQL. This is how we partition whenever we are working on the actual projects. So you should be knowing this, but I had already explained you about rank, row number, and dense rank. So please practice that. That's very important. Now I will give one more heading, which is lag and lead. Okay, I will say shift plus enter. I will define one more spec. I will say window date, or let's say I will say Jaswinder. Okay. It should not be that you are getting confused that is this mandatory that we need to use window. No, this is just a variable. Okay. So now I will say here window dot partition by, and obviously I will partition by department, and I will close this one, and then I will order by date. This time I will say order by date. Perfect. So this is how I had defined my spec. Now I will again say df dot select, and I will select couple of columns, name, department, and then salary, and then date. I will mention lag salary over this variable, which is Jaswinder, and I will name this as dot alias lag column. Similarly, I will copy paste and do the same thing for lead. We'll just change here to lead. So once I had defined that, by default, lag and lead works with one precedence, either on next one or either on previous one. But you can even define the precedence. But before that, I will just run this first to show you. This is how lag and lead is working. So the by default, I just told you it is 1. So even if you mention here the precedence 1, it will still give you the same output. See, but if you mention 2, it will start lagging and leading by 2 precedence. See, so it actually changed the output. So this is the flexibility of this PySpark lag and lead, that we can move n number of times further or n number of time backwards based on our requirements. But usually lag and lead is used to go one step, and I never personally used going 2 or 3 or 4 steps. So I don't think that there will be the scenarios. But yeah, you should know that there is this thing which is existing in the PySpark, and you can utilize it if it is required. Next up is aggregation window function. I will say aggregation window functions. I will say shift enter. These functions are like sum, average, max, min. So I will show you one. Again, we will define a specification. I will say jas underscore agg, and I will say window dot partition by department, obviously order by the date, and then I will mention dot rows between. Rows between, this is very important to note. I will start the bracket. I will say window dot unbounded. See, it is recommending me windows dot unbounded preceding, comma, window dot current row. So I had defined a variable. Now I will just use this variable inside my data frame. I will say df dot select. Let me grab it from above. Till this time it will be same, so I'll just copy paste here. Why to waste your time? So I will say here, let's say sum of salary. And obviously sum is only require one parameter, and then yeah, I will remove. No, I won't remove it. I will just change, let's say, average ABG, and then I will mention here, let's say, ABG, and here I will mention SUM, and yeah, I just need to change this over. I will just copy paste and my work should be done. Let me run this now. Oh, okay. I forget to remove the 2 from the average, but that's fine. Yeah, see guys, this is how we work with aggregation window functions as well. And we had literally covered all the window functions. Please do explore all the row number, rank, dense rank, lag, league, and all the sum, min, max. Okay. Please do explore that. These are very, very important. Okay. Let's discuss about UDF now. So I will just give a text heading saying UDF. UDFs are user defined functions, and these functions allows you to apply custom Python logic to your Spark data frame. Okay, so let's say you have to write something of your very own, then obviously you need to use UDFs. Okay, let's do hands-on as well. In order to use UDF using Python, I will tell you two ways to use UDF. First is the earlier existing way where we used to have Python code written and then we used to call the UDF. And the second way is to use the latest PySpark UDF functions to get the work done. Okay. So I will give you both ways. I will, let's say, method. I will name this as method 1 and shift plus enter, and yeah, perfect. So the first method is Python method. In this method, I will define a function. I will say define, and let's say I will define a calculate discount function. We will use this function, and then I will pass parameter price and discount value. Then I will handle the edge case that if my price is none, this is the edge case, then I will return 0.0. So whenever I write the Python, this is the personal tip I am giving out of the Spark sessions. First thing I do is I handle all the edge cases. So in this way, I eliminate the unnecessary part and then I just need to write the main logic to get my work done. The same thing I'm following here. First thing, I just eliminated the edge case. If price is none, return this thing. And if price is not none, then return price into 1 minus discount underscore value, and I need to divide this by 100, and that's it. This is how I had created a discount function. Now I need to register this UDF. So let's say I will create discount UDF, and I will use a function which is known as UDF, and I will mention the UDF name, and then I will mention the data type. I will say double type. So in this way I had registered my function as well. Let's give that comment as well, registering the UDF. Okay, so once the UDF is registered, we can use this UDF directly inside my data frame. So let's create another code, and I will paste my data set first here. This is the dummy data set which I had just created, and let's run this. Perfect. And let's also run this. Yeah, both of them ran successfully. Now I will create a data frame. I will say df underscore udf, let's say, and I will say df dot with column. I will create a new column. Let's say final price. Then I will use my UDF here. So what was my UDF name? It is discount underscore UDF. I will copy here and paste it here. And then all I need to do is I just need to pass my columns. The first column is price, and I guess it already guessed it. I will just click on tab and fill this out. And yeah, that's pretty much about this one. So let me display this. I will say df underscore udf dot display, and let's run this. Hopefully this will run. Okay, perfect. So I had successfully created a UDF. I had successfully registered the UDF. Then I successfully used the UDF inside my data frame and I also got the desired output. This is how we work with UDFs. Now let's talk about method 2, using UDF with Spark SQL. So this is also pretty much same. All you need to do is whatever the function you had created here, you need to register the function, but in different way. So here I will use spark.udf.register function and I will name the register, let's say SQL UDF. And then I will mention my Python function which we had created here, which is calculated discount. And I will just paste it here. And then I need to mention here is the data type, which is double type. And this is how I had successfully registered my function using Spark. And then I had just created the with column and I had did the same thing. Just I passed this in expression. I had passed my register name and I had passed my UDF name, the parameters, and then obviously the display function, and it had successfully displayed me the final price. This is the two methods. There is one more method. If I go to the documentation, let's say I search UDF in PySpark, search here and I will go down. Uh, but there is one more function which is using the UDF as a decorator. So you can literally define the UDF at the rate UDF and you can define it and then you can literally use directly inside the data frame. This is another way. Okay, and you can even return the data type if you want. So you can obviously try and explore that UDF. Okay, this is something which is not generally used. It is only used when you have a requirement which you cannot fulfill using the PySpark inbuilt functions. Okay, that's all about UDFs. Let's now try to understand write output modes. Let me give the heading write outputs. So in order to write outputs in Databricks using PySpark, we need to use modes. Modes are the behavior identifier and we have 4 modes. Let me create one more text. First is override, second is append, third one is ignore, and fourth one is error. These are the 4 modes provided by PySpark. Overwrite means it deletes the existing file and replaces them with the new data. Okay. And append means it adds the new rows to the existing file. Okay. And ignore means it silently skips the write action if data is already present. Okay. So it will simply skip if data is already present. And the error, it throws a runtime exception, and this is also the default behavior of the mode. Let's try to run this. I will use this DF only, this one, DF SQL UDF, and for that I will create another code. And here I will say DF SQL UDF dot write dot format. Okay, I need to mention the format of the output file. Let's say CSV. Then I will add backslash and I will move to next. And then I will say dot option. And obviously I will say header is equal to true. Header is true. And then backslash. And then I will say dot option delimiter. What the delimiter should be. By default, it will be comma only. But it's the good practice to mention the delimiter. And then I will say dot mode. If I mention nothing, it will be the error mode. But first time I will mention override mode and then I will say dot save, and in the save I will mention the location where I want this CSV file to be created. For that I will click on my catalog. I will go to browse there and then I will go to demo and and then here and then I will click on volume and I will click on these 2 arrows and I will mention the volume, and here I will create one more folder. I will say CSV override folder, and that's it, guys. So let me run this now. And perfect, it had ran successfully. Now I will just refresh the catalog and I will go to bronze and then demo and then obviously in volumes and external volumes. Then yeah, see here guys. So it had created a new directory which is CSV override as we had mentioned here. So now if I open this directory, I will see couple of files. First, few files will be metadata file and then I will be seeing a CSV file with a very stupid name. I will show you that as well. So see guys, so as I told you, let me expand this So I will get couple of other files. See guys, so I got the CSV files based on my data. So this is how the mode override works. Because it had divided the file data into multiple partitions, that's why I am able to see 3 CSV files. Okay. If I rerun this, I won't be able to see any additional files. I will still be able to see 3 files only. Let me show you as well. Let me refresh again. Bronze, demo, volumes, and then external volumes, then CSV format, and see. These are still 3 files. So overwrite will delete the existing files and replace with the new files. Earlier it was 131, 132, 133. Now it was now it is 134, 135, 136. Make sense? Similarly, if I instead of overwrite, if I mention append, and I will change CSV override to CSV append, it will create a new folder with the CSV append name. Let me show you. Going to volume, then external volume, then CSV append. Then here you will see the 3 files. So if I rerun these one, it had ran successfully. Now let me refresh it. Go to bronze and then demo and then volumes, external volume, CSV append, and see guys. Now this time it had created other set of files. But in CSV override, it was overwriting the existing files. So now this time it had created the another set of partitions. This is how we can work with override append. Similarly, ignore will simply ignore if the files are already loaded and the error is the default one. Okay. So please do practice this as well. This is how we can write the files using PySpark. Okay, so now we had discussed a lot about modes and we had even loaded the CSV files. But usually in the projects, it's not always that we are just working with CSV files. We are also working with JSON files, then Parquet files, then Delta files. Let's also try to implement that as well. I will just run the above script by tweaking that. So I will first do for the same with the JSON. The format and everything is the exact same as the JSON. All I need to do is I just need to remove these two things. Okay. And obviously I need to mention the mode as per the requirement. And then I need to just say instead of CSV, I just need to say JSON. That's it. And I will place this inside my JSON folder. So this is pretty much all about the JSON. Let me run this now. And let me parallelly go to catalog, and then I will go to bronze layer and then demo, then volumes, then obviously external volumes. Here I am seeing JSON.append folder as well. This means my JSON ran and I can see it had ran successfully. I will click here and I will be able to see the JSON files as well. Similarly, the same thing will be repeated for Parquet files. Nothing much here, to be honest. All you need to do is just change the JSON to Parquet. I will say Parquet, and here also I will say Parquet. And let me rerun this as well. And let me refresh. Again, I will go to bronze, demo, and then I will go to volumes, and then I will go to external, and then I can see the Parquet dot Parquet underscore append folder as well, and I can see the Parquet's files as well. The last one is the Delta format, and this is the one of the most optimized and one of the most widely used as well. So Delta format is the advanced version of Parquet format, where in Parquet format we don't have any kind of ACID properties, commit rollback, and save points. In Delta file formats, we have the transaction log. Whenever we create the Delta files, it creates two things. First, it creates the Parquet for file, and second, it creates a Delta log folder. And inside the Delta log folder, we have two kind of files. First is JSON file, and second is CRC file, which I guess is known as cyclic redundancy check something. Okay, so let's implement the Delta file as well. I will just copy paste the Parquet code and I will just change from Parquet to Delta. So see guys, it is very easy to write in any format, right? This is the beauty of PySpark. Let me run this and let me just refresh this once this ran successfully. Okay, perfect. And then it is refreshing. And here I can see the delta underscore append folder as well. And if I open this folder, you will see two things as I just discussed. First is Parquet file, and second is this delta log folder. And inside this, as I just discussed, we will be having CRC files and JSON files. So this is how you can load multiple file formats using PySpark. Cool. With that said, we had successfully covered the PySpark transformations, and I really hope that you are very, very clear about all the most widely used transformations. Please do revise them as these are very, very important. And if you have any doubts, just ping me in the comment section, or if you want to have any one-on-one connect with me, feel free to book a call with me on TopMate. And that's all, guys. Thank you so much for watching. Have a really nice day.